Welcome dear students. Here we start to learn the next topic which is related to the CHG-290 course, that is organometallic chemistry. Last time we start to learn that is the some unique reaction which is always occurs in the organometallic chemistry. We already discussed the two reactions, that is what? Oxidative addition, and the second one, that is reductive elimination reaction. All these two reactions we will learn in the last lecture. Today we are going to learn the migratory insertion and the beta hydrogen elimination reaction. So start our topic. First, that is migratory insertion. What is the migratory insertion? That means here consider this is our organometallic compound. This is two ligands which is attached to the central metal. Okay, then what happened? This Y which is inserted in between M and X. In the intermediate stage, this is look like this, and then by the addition of the ligand here, this there is a what happened here? There is a formation of empty space over here. Okay, this Y is inserted to here, and then there is a formation of empty space, and this empty space is fulfilled by the addition of the incoming ligand like this, and there is a formation of like this molecule. In this case, there is no change in the formal charge on the metal. Here, if this metal has a Dn charge, then in the final stage, this also metal have the Dn oxidation state. That is, what is the condition for this? There is no change in the formal oxidation state of the metal. Okay. Second is what? The vacant coordinate site is generated during the migratory insertion. That means what? Whenever the migratory insertion of this Y group is takes place, or this X is inserted, then what happens? There is a formation of this vacant site. Vacant site. Okay. Then this vacant site is fulfilled, or which gets occupied by the incoming ligand. Here this L ligand, this vacant site is occupied by this L ligand. Next is what? Next condition is the group undergoes the migratory insertion. Whenever that molecule shows the migratory insertion, these two molecules which is to be placed in the role of migratory insertion, they must be in a cis position to one another. Okay, if we consider this CH3CO, okay, then what happened? This CH3 which is what? Inserted. Okay, then what happened here? This after that there is a formation of vacant site to here, and after this formation of this vacant site which is fulfilled by this PPH3, and we get like this molecule PPH3 which is present to the CH3 position, and this CH3 is inserted. Okay, this is, there is a formation of COCH3 molecule. Okay, these reactions are enthalpy driven, and although the reaction is entropy prohibited, the large enthalpy term dominates. Okay, this is called as a migratory insertion. That means two ligands which are present in the cis position, they migrated and inserted in between the metal and the ligands, okay, which are present in the cis position. That is called as a migratory insertion. This migratory insertion has mainly two types. First, that is called as a 1-1 migratory insertion. 1-1, that means what? Here this is the A atom, that means this metal is directly bonded to the A atom, and this X group also directly bonded to the metal. Then this X is migrated to this 1. This is 1 position, and this ligand also has a 1 position. Okay, that means this removing ligand which is attached to the atoms which is directly bonded to the metal. Okay, that is called the 1-1 migratory insertion. You can see this X is attached to the A position, not the B position. Okay, if this is like this molecule, this is the one atom and this is the second atom. Okay, if the migratory group is attached to the first position which is directly bonded to the metal, that is called as a 1-1 migratory insertion. You can see by breaking this bond, here this X is directly attached to the A position, A ligand. Okay, and 1,2 migratory insertion is what? If the metal which form a pi bond with the molecule, then if this is the 1 and this is the 2 position, that means these two atoms which is symmetrically bonded to the metal, or they have the same distance from the metal atom, then this migratory group has the confusion to where to bond. Okay, then what happened, whenever this X group is bonded to the 2 position, and there is a formation of like this structure M A B X, that means this is A is 1 and B is 2, that is migratory group is inserted to the second position of the ligand, that is called as a 1,2 migratory insertion. Let me see the example. This is the example of 1,1 migratory insertion. What happened here? This is RH, this is carbonyl which is having one which is directly bonded to the rhodium. This is a migrating group, and here this is the CH2, this form a single bond, this form a sigma bond with that of the RH. Okay, and then what happened, this CO is migrated, this is migrated to this is one position, this is one carbon, this is a 2 carbon, but this carbon which is inserted in carbon number 1, you can see here. Okay, this is carbon number 1 and this is carbon number 2. Then this type of insertion is called as a 1,1 migratory insertion. This carbonyl is inserted to the carbon number 1, or we form the bond between metal and the carbon number 1. That is called as a 1,1 migratory insertion. Okay, let me see another type of the insertion, that is 1,2 migratory insertion. What is the condition for this 1,2 migratory insertion? Here this metal which form a pi bond with the molecules. Okay, that means this molecule which has a pi system, and this pi system which is bonded to the metal. Here in this case this has eta 1 position, and here this has a eta 2 system. This is the eta 2 system. Okay, in the coordination chemistry you already learned what is eta 1 and the eta 2. Okay, here these two atoms having the same distance with that of the central metal, and that's why this is the eta 2 system. If eta 2 system is there, that time what happens, this is the one position of carbon and this is the second position of carbon. Okay, and sorry, this is this is CH2 CH. Yes, here yes 1 2, whenever this hydrogen is bonded to the second position of the carbon, then there is a what, this is the CH2 and this is CH. How the structure is this? This is a RH and this is bonded to like this CH, and this is R, and this is what, CH2. Okay, and here this is the hydrogen is there. Migratory group is hydrogen. This hydrogen, this is carbon number 1 and this is what, carbon number 2. Okay, whenever this hydrogen is bonded to here, then what happens, this bond is going to break and they form a single bond, and here they get converted to what, this is the RH, this is bonded to one position, carbon is directly bonded to the RH group, and then this is the CH2, and here this migrating hydrogen group is attached to the second position, that is this second position has CH, one hydrogen, and whenever addition of the another hydrogen, it get converted to CH2R. Okay, like this. Here there is this type of insertion is called as a 1,2 migratory insertion. You can see here there is a formation of CH2R. Okay, that means this migrating group is attached to the second number of carbon, that is called as a 1,2 migratory insertion. This is about the migratory insertion. Second, we are going to learn that is a beta hydride elimination. Okay, what is this? This beta hydride elimination is a reaction in which the alkyl group, which must be having a beta hydrogen, this is alpha and this is the beta hydrogen, you can see here, must contain the beta hydrogen, and the sigma bond, they form a sigma bond to the metal, they must be form a sigma bond to the metal. Okay, and then it get converted to the corresponding metal bonded hydride and pi bonded alkene. After the addition of these elimination, here there is a formation of alkene. What is beta hydride elimination? It is a reaction in which a alkyl group having a beta hydrogen, alkyl group, here this is the alkyl group CH3CHR. This is the alkyl group. This alkyl group having a beta hydrogen, okay, and sigma bonded to the metal center is converted into a corresponding metal bonded hydride. That means this is the metal and hydrogen bond, that is called as a metal bonded hydride, and pi bonded alkene. There is a formation of what? Pi bonded alkene. This is a pi bonded alkene. Okay, the alkyl must be, for this beta hydride elimination, the alkyl which is must be have the hydrogen on the beta carbon, and for instance the butyl group can undergo, mostly the butyl group can undergo this reaction, but methyl group cannot show the this type of the reaction. The metal complex must, and the second condition, what is the condition for this? Here the butyl group shows this type of the reaction, but methyl group doesn't show the beta hydride elimination. Second condition is the metal complexes must have the empty or the vacant position, okay, to the addition of the hydrogen, and this vacant position which must be to the cis, to the alkyl group, then only this reaction will be occurs. Okay, then no, in this case also there is a no uniform change in the oxidation state of the metal. Okay, let me see the mechanism of that. Here you can see this is the metal, this is the alpha carbon is there, and this is the what? Beta carbon is there, and this beta carbon has the hydrogen, you can see in the red color. Okay, then what happened here? Whenever this hydrogen is bonded to this metal, and then what happened? This metal which break this bond and goes to the pi position. Okay, then this type of bonding, breaking and making of bond is takes place, and then this hydrogen is directly bonded to the metal, that is called as the metal hydride, and these metal which form a double bond with that of the alkene group. Okay, this type of reaction is called as a beta hydride elimination reaction. It can be a vital step in the reaction or an unwanted side reaction. Okay, let me see some example of the insertion and the beta hydride elimination. Okay, first, that is insertion of CS2. That is, this is the CS2 group. Okay, and this CS2 group which is, okay, this is CS2 group which is inserted in between this R group. This is the migratory inserting group. Then what happened? This sulfur which is directly bonded to the manganese, and there is a formation of like this structure. That means this CS2 is inserted to this manganese, and here this is migrated. Then SO2, same manner, this sulfur which is bonded directly bond to the manganese, and here this R group get migrated. SO2, here Me2, this here in that case another type of migration will take place. How? This oxygen is form a bond with that of the titanium, and then here this twice Me which is bonded to this sulfur. This is the oxygen bonded system, and this is a sulfur bonded system. Okay, next, that is a beta hydrogen elimination. This is also called as a retro migratory insertion. What happened? This metal which must be have the vacant side. This is a vacant side. Okay, then what happened? This is the alpha carbon, and this is the beta carbon. This beta carbon has the hydrogen. This hydrogen is what? By breaking this bond, this hydrogen is form a bond with that of the metal. At the same time, this metal form a pi system or pi bond to that of the alkene, and there is a formation of like this tip. And then further, by breaking this bond, we get LNMH, that is metal hydride compound, and the alkene compound. all this reaction we will learn in the number of cycle. Okay, the next lecture. Here we conclude the different type of the reaction which is always used in the organometallic reaction. Okay, you have to remember all this reaction because we will use all this reaction in the number of organometallic cycle, that is a Monsanto process, Wacker process, hydroformylation process, or the cycle, etc. Okay, so thank you very much for your attention. Next time we will learn the next topic which is related to the organometallic chemistry. See this lecture and write the comment by writing your name and roll number. Thank you very much.